Chemical engineering is taking the math and chemistry that you would know, or the chemistry you might do on a benchtop, but using those skills for societal needs, and often at scale. We help the world have clean water and clean up wastewater and have sustainable food and clean energy, but we also help make the medicines and drugs that help people stay healthy. We help clean up the environment, we make materials, we make polymers, we make biodegradable polymers. So we're trying to do all these things sustainably so we don't compromise the needs of future generations, but still fill the needs of society today. At Melbourne University, engineering starts on day one in your Bachelor of Engineering Systems. The pathway of the Bachelor of Chemical Systems is your first steps to becoming a chemical engineer. Now, your first year looks quite general. You'll probably learn about chemistry and math, and you'll take a set of engineering subjects that expose you to a lot of different disciplines in engineering. And then the second and third year really hone in on chemical engineering. You learn some of the fundamental concepts in chemical engineering, such as chemical reactors and fluid mechanics, and then that's pulled together with some very real-world and applied subjects that show you how chemical engineers solve problems. Well, certainly what's exciting at Melbourne is because we have the Bachelor of Science in Chemical Systems that feeds into the Master's, is that we are able to provide students a very hands-on experience with a good theoretical background. And because we have those 5 years, we can show you a pathway to chemical engineering, but offer you a lot of flexibility, particularly in industry internships and research experiences, where you can work in a department that's strategically positioned to work closely with industry and has a world-leading reputation in solving industrial problems through research. So when I ask students what they really like about the course, they often tell me the thing they like is the hands-on part, the chance to connect theory to practice, and then shifting it to an industrial focus, to be able to see how research fits in with industry, but also the student experience. We have a student society that is just fantastic. There's a lot of social events, but it's also professionally focused, and a lot of them find their first internship, their first job opportunity might come through the student society. So the Master's in Chemical Engineering takes all the good bits from the Bachelor of Science in Chemical Systems and then puts them on steroids. You get to really get into the detail and the exciting, complex aspects of how chemical engineering works in the real world. And we're going to do that through a combination of core subjects and really interesting electives in food, pharmaceutical processing, environmental wastewater. It depends on your area. There's actually specializations even in sustainability and environment and materials and minerals processing. Now, one of the big things about the Master's is then it pulls things together in a capstone project that gets you to think about how chemical engineering works together. And along the way, you're going to have a path that's going to offer you industry internships, chances to work with companies, and a chance to build a professional network through your other students. And there's an amazing cohort experience through our student societies and industrial mixers. And it's that whole experience in the Master's that is really an exciting extension of what you've learned from the first 3 years. Chemical engineering is clearly a skill set that lets you work on the design and development of processing plants to make chemicals. We make chemicals, we make polymers, we refine petroleum into petrol. And that's absolutely what chemical engineers can do, except when it's not. Because that same skill set can let us develop products that are used in our everyday lives. We make beverages, we actually make Mars bars, we help process milk, and we can have engineers working as process engineers or development engineers in quite a few different areas. We make the vaccines that people are using today, as well as other drugs and pharmaceuticals. We also help keep water clean. We could be actually working at a plant to make sure your drinking water is safe, or we could be working at a wastewater plant, making sure that what we make as wastewater doesn't go out to hurt the environment. It can even let us do amazing things like help contribute to designing the artificial kidney. And it's the skill set of this combination of chemistry and math and physics that really allows us to tackle a set of problems for the jobs that exist now, as well as the jobs that don't even exist yet.